Good morning, my chickadees. Thank you for coming along. Who do we have? A whole bunch of people. Okay, let's get some semblance of order into this. I think this is likely. Oh, excuse me. I don't know what happened there. I think this is likely to be a more subdued live stream than usual, just because of the mental mode I'm in, etc., and what's going on and things I'm working on. Alright, before I get into that, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Thank you. The chat is up. We have TTS. Yeah, that's right. So as I was saying, my state of mind and the mode today here in Melbourne, it started raining sort of during the night. It's been a steady drizzle. It's still raining now. It's like outside it's a cool day. You might hear a bit of rain on the roof here. So today is like one of those perfect days to be snuggled up in bed with someone you love. So if you have the opportunity to do that, that's what you should be doing, not being here watching a live stream or doing a live stream, which is even worse. So I am going to, today, what I want to do is have a look at this, and that's the new chassis. Whoops, not that. That's the new chassis for the the new chassis for the PCB conveyor.
And hello from Chicken Pasta World.
Who said that? Who said that? Oh, Henrik. Chicken Pasta World. Yeah, Henrik sends me pictures. What? Okay, DIY. You're trying to get my energy level up. I don't think it's going to work today. Thanks, DIY. Yeah, so I'm going to be doing some work on the stream on the PCB conveyor today. But so the goal with these Project Dopamine episodes is to make solid progress on something and to actually get to the end of a project, or get it to the point where I can say, yes, I'm satisfied with that. It's like a checkpoint and I can move on with doing other things. But there are a few other little bits of news, I suppose, other things I want to talk about just before I get to the PCB conveyor. In chat, who was it? Someone was saying, I hope there's an update. Where is the chat? I have lost the chat. Totally lost it. I've got the TTS there. I've got the YouTube studio there. Oh, there's the chat. Okay. It's hiding at the back. Here we go. So someone was asking about an update on Test-O-Matic. Oh, here it goes again. This time for Henrik. Thanks, Henrik. So Henrik regularly sends me pictures of what he has cooked. I think it's his mission in life to make sure that I am perpetually hungry. I should say hello to people as well. Someone said, hope there's a Test-O-Matic update. Simon, that's right. It was Simon who wanted a Test-O-Matic update, so I will provide that as well. But first, there's only one T there. Good morning to Henrik Don from NZ, Gerald42, DIY in the Ghetto, Crispian is here, Simon is here, Stephen W, Sharky, Stephen George, Tech Nebulous, just clicking, David Howes, Russell Rainey, Jordan Reese, Tabraze, welcome to Braze, Paul Schultz, teleporting in from Adelaide, Mark Laguda, Imi, teleporting in from Ballarat, Gavin Jackson, I have no idea where you are teleporting from, Gavin. Nearby. I just got to scroll back down again. Stephen says he's trying to fatten you up, ready for the market. Right. Crispian says Jono is lost or has lost it. That is right. Prestonia, yeah. Gavin commutes all the way from exotic Prestonia. So anyone from Melbourne would know exactly, where that is. But Tassie Bob, morning. Well, for you, it's all in the name, isn't it? Jordan is teleporting in from Reno, Nevada, USA. Welcome, Jordan. Okay, so there are a couple of things that I want to get through here. Rob Tillart, here we go. Okay, I'm just pulling up some stuff on GitHub. Throw it up here, make it easy to see. Okay. This is something I should have prepared earlier. Rob Tillart, library. Here we go. All right. So many of you will know the name Rob Tillart. Crispin says, how about the fire up Glasgow Road? I used to live right there. Yeah. Okay, so there is a very big fire right now just up the road from me. It's pouring rain. It's been raining for hours. And there is there's an area up Glasgow Road in Kilsyth, and a fairly large area has actually been evacuated. People have been leaving their houses that adjoin the reserve area, because during the night there was quite a big fire there. And from what I heard, this is just like scuttlebutt on the Facebook, there was a group of kids who were seen running away from the area about 10 minutes before the fire was reported, and the fire seems to have started in multiple locations. So it seems like someone has been out there just setting fires. John Whips, good morning. So good morning to Tassie Bob, Curtis Brooks, John Whips. Thank you for joining the chat. Henrik, yes, the lab is going to be okay. I am far enough away that it is not a problem. So there was the fact.
Ostrov said, sad to hear, is your lab going to be okay?
Yeah, it'll be fine. Austin is here. Yeah, there was there are some guys who have a performance car place just 2 factories behind me. Not the one directly through my back wall, but the one on the other side of that wall. And about 3 o'clock this morning, they brought a car down, it was a race car or something. They brought it down because it had been stored at a house that was right adjacent to the parkland where the fire was. So they were rushing around during the night and getting the car out of that location and moving it, and they put it in the factory down here at like 3 o'clock this morning to bring it to safety. Yeah. Jordan, yes, big fires, no joke. Dealt with one in 2017, destroyed 3,000 houses in the Santa Rosa, California area. Yeah, big fires are no joke. So as big fires go, this is not a big fire, but as fires in an urban environment go, this is pretty decent size for Melbourne, because it's in parkland that is in an urban area, so surrounded by houses, with the potential to cause a great deal of mayhem if it gets out of hand. So luckily that has not happened. And I think with all of this rain that's coming down right now, it is lowered the temperature dramatically. We won't have problems with embers being blown, which is a potential big problem, because if embers had been blown up onto Mount Dandenong and we had fires that originated more like around the Montrose, the Basin, that sort of area, and went up the hill, could be really, really bad news. Don't think that's going to happen now though. So, where was I? That's right, what I was talking about, I'm going to get through a couple of things here. An update on this, and I'm going to grab the chat and move it up to here. Yeah, so if you have done anything with Arduino at all, anything involving a library for like a driver for a sensor or something like that, you've been in the Arduino IDE searching for a library, you have probably come across a library by Rob. And okay, so backstory. I'm going to back up, way back up, roll it way back up. What I'm talking about here is the AD5593 I/O expander, which I designed into a module for the Test-O-Matic. And the idea is that it's a module that is generic, can do digital in, digital out, analog in, and proper analog out, because it's a DAC as well. It's not just PWMing out, it is proper analog out. And I need to be able to control it out of Python on the test runner, on the Test-O-Matic. So I started looking around for Python driver libraries. There is a pretty crappy-ish looking one for MicroPython, and it seemed, from what I could see, it didn't seem to be maintained. And I did a couple of experiments with it, and it seemed kind of broken and not very nice. So I then started writing. I started writing my own driver, like my own Python driver for that particular I/O expander, and I was having trouble getting the. So this is just explaining my thought process, like the sequence of events that led us to the page that we're looking at right now. I was in a situation where I needed to validate the hardware because I was trying to write the I2C driver in Python and I wasn't getting the responses that I was expecting. So I was initializing the registers to set the I/O pins into the right mode. I was trying to drive sorry, there's stuff going on in the chat and I will get back to it, but yeah. I'm just going to be chasing squirrels perpetually unless I get through this. So, unless I get through this sequence. So, I was in the situation where I was trying to set I was setting the registers, or I think I'm setting the registers. I was sending commands to do things like drive I/O pins high and low, and I had the scope on the output pins, and I wasn't seeing anything. So, in that situation, is it hardware? Is my design invalid? Or is it software? Was my driver invalid? It's the classic conundrum. So I wanted to try to bisect the problem, and it's the classic binary chop thing. You've got a problem space that's this big, so you cut it in half and you figure, is the problem in this half or is the problem in this half? I wanted to validate that my hardware was working correctly, and before I bash my head more against the driver, because maybe I'm trying to get the driver to work and the hardware is not working and my driver is never going to work. So I went looking for Arduino driver libraries so that I could just take the chip. In fact, I'm going to fire up Fusion because I'll show you something else that I did as a result of this. So I took the chip, hooked it up to a Freetronics 11, which is basically an Arduino Uno compatible classic AVR 8-bit, and went looking for drivers for that so that I could at least exercise the hardware and make sure that the module is doing what I expect. In fact, I'm going to go to, let's go to here and go to GitHub not that. I'll go to that IO mod. Yeah, that'll do. And so I wanted to check whether it was working. And I found the Arduino driver situation is as dodgy as the Python driver situation, sadly. I found one driver that seems to be, it's very incomplete. It only has a couple of functions on the chip. One thing that it does is that it runs the pins as a DAC. So I use that library, I can't remember what it's called now. I use that library on the Arduino and generated a sine wave and put that on the oscilloscope, and I could see, yes, it really was generating a proper analog output. So that validated that my hardware is correct to some extent at least. So I can address the chip over I2C, I can put the I/O pins into DAC mode, and I can drive different voltages on the output. So that was like a hooray, the hardware isn't broken situation. But then I needed to exercise the other functions of the chip because I want to see examples of how the chip works. So I just went looking for other driver libraries and I came across this one by Rob. Now, getting back to that other part of the story. So this is the Arduino library list site, which has heaps, and basically it's just like an index of libraries so that you can look them up, you can see what they do. It's got information about them. And this is the author page for Rob Tillart. So yeah, you can see he's written, for example, an Arduino library for the 74HC138 3-to-8 line decoder multiplexer. And there's one for the 154, and here's one for the 1301 magnetometer. And I'm just going to start scrolling. And if you can see the scroll bar on the right hand side, you can see how slowly it's going down. Oh, look at this. Arduino library for async reading of an analog pin. Atomic weight. Arduino library for atomic weights. Calculate mass percentage of elements in a formula.
_creations said, that issue of chasing drivers is why I had to buy dev board communicators so that I could write and confirm my driver was working correctly.
Yeah. Yep, it is a challenge, Austin. Arduino library for complex math. Determine correlation between X and Y data set. Where was this? 10-bit DAC? Oh, Arduino library for the I2C DAC 53001 10-bit DAC. So, like, I'm not even halfway yet. I'm still scrolling, I'm still scrolling. So these are Arduino libraries that Rob has written. I'm still scrolling. This is just insane. I don't know how many there are on here. I haven't, what I could do is copy this, chuck it into the terminal and throw it through. In fact, I'm tempted to do that. And throw it through WC -L. Let's do this. It doesn't give me a count. So let's find a terminal. vimrob.txt. Alright, so, oh, I didn't even need to do that. 299 lines on this. No, 298, because I had a blank line to start with. Okay, 298 Arduino libraries. So we've got water mix. What? What the hell, Rob? What are you doing? Rob is a maniac. Look at this. Water mix. Arduino library for mixing water with different temperatures. What? Wave mix. Library to mix two signals, A and B, with an adaptive weight. Yeah. Statistic. Library with basic statistical functions for Arduino. Anyway. Yeah, okay. Rob is a maniac. And so I came across, but this shows even more of what a maniac is. So this is the AD5593R, which is the I/O expander I've got on the module. And look at this, he wrote this 2 months ago. And if you look down in the, look at this. The device is not tested with hardware yet. Feedback welcome. He doesn't even have the hardware for this. He just he thought it looked like an interesting chip, grabbed the data sheet, read the data sheet, and then implemented the library like blind without without even being able to run it on the hardware. And then created these, yeah, so there are all these explanations, things he's pulled out of the data sheet. So he's created the API and all of this, etc. Add missing functionality after basic functions. So yeah, so I grabbed this library and tried it, and short answer is it didn't work. And I am not in the least bit surprised that it didn't work, given that Rob did not even, he could not test it. All he could do is compile it and see if it compiles. So I then, oh, where are we? Issues 1. So I opened an issue because in the repo it said that it needed to be tested with real hardware. So I opened a bug basically in order to be able to report tests, provided information about the hardware and the test environment that I set up, some of the things I discovered, because the way the data sheet is written, it looks like the I2C addresses should be hex 8 and 9, but in fact it comes up on the bus at 10. And if you pull A0 high, it comes up on the bus as 11. We saw that when we were doing the I2C scans and when we were testing the multiplexer on the previous live stream. And we found that it came up on 10. So he did it based on what the data sheet said, and the way the data sheet is worded, it looks like that should be coming up on 7. Oh, sorry, 8. Like that is the 4th bit across if you've got LSB to the left, so you're doing big endian or whatever it is. So we've got the 4th bit across, it means that it should be a value of 8. And then if you set the next bit, if you set the least significant bit, it should move to an address of 9, but it's not. It doesn't actually do that. So I just gave him some info with outputs. So this was outputs with his library and showing what results I was getting with different things after I'd modified a couple of things in his examples to make them work. And this was analog inputs, so I was getting bogus values coming in on analog inputs. And so Rob has now started digging into this, which is really cool. Yep, so he's made some notes, asked me for some feedback on tests, which I subsequently did, and he's created a development branch with those changes, and then I did some more testing. So yeah, I hadn't actually tried up until this point with pulling addresses A0 high, but I verified that yes, it really does make it go from hex 10 to hex 11. Yep, so he's continued doing work on it and done a bunch more. Yeah, anyway, really cool. So Rob is on the case. He is now working to make that library work, which is, yeah, it's so impressive that he's doing all of this. So I'm going to send him some stuff. Oh, that's right. So what I did, when I was doing some testing with this is a 2mm pitch module, which means you can't put it in a breadboard. And I'd like to have 2mm pitch breadboard. That'd be cool. But anyway, this doesn't go into a breadboard. And so so I've offered to send him hardware, and he has accepted my offer. And I'm going to send him some of these modules.
Austin's_creations said, based on his most recent comment, seems like he need hardware.
Yes, exactly. So I am what do you see in that bug thing there? That is just the public discussion on the bug. We also have a private email thread going on where we've been talking about it. So he's given me his postal address and I'm going to send him some hardware. However, because this is a 2mm pitch, it was a little bit of a pain to do testing. I ended up soldering jumper wires onto the tops of the pins so that I could then plug them into the Arduino. And yeah, TTS took us time to state that. And that's a bit of a pain. So I then designed this during the week. So this is a 2mm to 2.54mm pitch adapter, which will make the module breadboard friendly. And that is in the queue at JLC PCB right now. So this little adapter, it's a totally trivial board. It's, in fact, I think it's even single-sided. All it does is directly map pin to pin. So it doesn't care what the module is, that doesn't care which one's ground or anything. It just passes the pins through. So once I have those adapter modules, I will send the IO mod hardware with the adapters to Rob so that he can chuck it on a breadboard and do some testing and make progress on that, which is really cool. And it's awesome that Rob is willing to do that. But the thing is that is not, even that is not the end result of where I'm trying to get to, because ultimately I need this to be I need this to be usable with Python. So I need a Python driver for this. But what I'm doing is using Rob's work on the C++ driver to validate how to interact with this, because I still do not have a good example.
Scott Miller said, "Why can I now see John designing all sorts of stuff at 2mm pitch in that form factor now?"
Yeah, all modules should be 2mm pitch. So the, where was I? Yeah, so going through this process with Rob and getting his library, where are we? Back to here. Getting his library working means that we will have a way of working with that chip which is known good, and we'll have information about all of the registers and the sequences of how we configure yeah, of how we configure the IO pins to put them into the correct mode. But then after that, I need to rewrite it in Python. But Rob is doing all the hard work for me right now and doing the C++ version. Although it could be done, as a binary that gets compiled on Linux. Just do it in C++. But yeah, then there'd be issues with, would I do that as a Python library, like an embedded, a C++ driver embedded with a Python wrapper, maybe? Maybe. I don't think it's worth it. I think it'd be better to re-implement the driver in Python. So that's going to be a bit of an interesting learning curve for me. But yeah.
Austin's_creations said, "It is almost like manufacturers should make datasheets that actually work."
Yeah, it'd be good if manufacturers made datasheets that actually work. And Henrik asked, TTS is about to say what Henrik is saying. Here it comes.
Ostrov said, "Can AI help with the Python?"
Possibly. I was using ChatGPT a little bit on some of the Python stuff, and that's when I got into the situation of I didn't know whether I could trust what it was. Oh, hang on. I'm going to click to say. I'm trying to say Jack's text thing. What does that do? No? Does? Hang on, I'm going to try that again. Play.
Does.
No, the whole message. That's weird. it was meant to say, does Adafruit have a driver for it? They do not. They have a driver for a very, very similar part. So this is
Jack's Tech
based
said,
on...
at Jack's Tech.
Yeah, I don't know why I didn't do that. That bit where it says does, if I just click on does.
Henrik Ostrov said, the Win 11 UA should be really good coding.
When it was saying does, that was me clicking on it to say play your message.
Does.
Yep. Technebula says, if you look at the address of the AD5593, the address should be 10 or 11 as the address is left adjusted. On page 20, the address is clearly indicated. Yep. Yeah, so that's right. So what we're seeing is 10 or 11. So left justified and then left adjusted, and then they left off the last bit. So they only show 7 bits of the address, and it should be aligned left, not aligned right, which is kind of weird because normally if you were showing a binary number, you would show the least significant bit up, so that it's weird that they show it with the least significant bit missing, which means that you end up mentally bit shifted one across. Last bit is RW. Oh, interesting, Technebulous. Cool, thank you. I have not read that part of the data sheet, evidently. Yeah. Okay, so the question about Adafruit having a driver. Adafruit has a driver for the AD5693, but not the 5593. Now, the 5693 is similar, but not the same. I think it's just a DAC from memory. Yeah, so they make a module with the 85693 on it, and they so what I was thinking of doing, yeah, they make a Python. What do they make for? I can't remember. Anyway, this was a week ago or something, like during the week that I was looking at this. I think they have a Python driver for the 85693, and which is a DAC, and I think that is probably Jacksec says there are 10 types of people in the world: those who can read binary, those who can't, and those who realize there are other number systems than binary. Yes. All right, so what number system would have 10 represent a decimal value of 3? It would be, that would be a trinary number system, because the place value of a 1 in the second digit would be decimal 3, I think. So 0, 1, yeah, it's trinary. So a value of 0 in the first is 0, a value of 1 in the first digit is 1, a value of 2 in the first digit is 2, a value of 1 in the second digit and 0 in the first digit would be 3. So it's trinary. 3 to the power of 1, says Paul. That's right. Yeah, we should do everything in base 3 from now on, just to confuse everybody. So, where are we? What am I? Yeah, so anyway, I've got to get, the upshot of all of that is there is probably going to be quite a pause now on Testomatic, because I've got to get over this hurdle of the of these modules. What I could do is make modules based on something else. Like I could make an MCP 2307. No, I'd use probably a 008, like an MCP 23008, just to be able to do digital I/O. But as like an intermediate thing until I get the driver sorted, because there are plenty of known good drivers for that. So I could build alternative I/O modules around known hardware with existing drivers, which is probably a sensible thing to do. Austin says, Austin says, here it comes. It'll catch up. TTS will catch up. Yeah, anyway, so that's the update on Testomatic. I have a couple of...
Austin's_creations said, that's okay, we'll be able to finish off the AQS.
Yes, the AQS. I want to do a live stream about that with Austin, ideally, if he is up for being on the stream again.
Scott Miller said, design a module with an RP2040.
Yeah, Scott. Now you're talking. That's the sort of thing that I was considering doing with an RP2040. Okay, so if your mindset is along the lines of putting an RP2040 on it, another way to do it, this is something that the timing is just not quite right. I really want this. The serial one, but here we go. I know I've talked about this before, but this is a PIC based. Is it PIC? I can't remember. Maybe serial wombat. Where? Come on, surely there is a where is the link? I'll bring this up on screen in just a second. Okay, so this is serial wombat. It is a microcontroller. This first version was a PIC, and it is an I/O expander that does heaps of stuff. Yeah, so you can communicate with it via UART or I2C, which is perfect. It gives you a bunch of I/O pins, and you offload functionality. Now, where's the Kickstarter? Click here to see the latest serial wombat. Now, this Kickstarter has not yet started. It's actually been launching soon for a little while, and the moment this goes live, I'm going to be backing this because I want some of these. But these things, I mean, his pinout is different. I would basically make my own version of what's on the screen right now. Oh, going active April 1st. Okay. So what this provides you is 8 I/O pins, which is kind of handy. I2C, power, ground, and the because this is basically a microcontroller with firmware on it, you can communicate with it from your main microcontroller, and each of the pins can do different things. So you can run pins as ADCs, you can do PWM output. It's got built-in H-bridge control, it's got servo control, PID and hysteresis, things like rotary encoder input. So what you can do is you can tell it that some of the pins are rotary encoder pins, and then it'll do all of the decoding in itself, and then just pass the results back to you over I2C or serial. Pulse timer input, debounce button input, matrix keypad, I2C over UART, so you can actually generate UARTs on those I/O pins and communicate via I2C to this thing. Anyway, pretty funky. So stepper motor control, IR remote decoding. He wants to try to do NeoPixel control. So the idea with this is that you configure the I/O pins and they go into a particular mode, and then all of the processing and management of those pins is handled within the microcontroller. So it's like a smart I/O expander. Anyway, that is one option, and he's already, excuse me, and he's already got all of the firmware running for doing this. And this is like an update on the, now where was it? It was with the CH something. Where are we? It's done with the CH32V003, which is that super cheap little microcontroller that, yeah, the little Chinese one.
Henrik Ostrov said, can UMN open Copilot Web and ask about the Python driver?
Not right now. Henrik, it's a good suggestion, but I do actually want to do some...
Scott Miller said, keyboard mouse emulation module for Testomatic, HHHMMM.
Yeah, Scott, so you could do all sorts of interesting things. Once you've got a microcontroller doing on your I/O module, so your I/O module is kind of smart to some extent, it opens up all sorts of possibilities. So this is an option as well, is I could do an I/O mod with one of these serial wombats on it. But the new one is not quite ready, and the old one It's it, yeah, because it's the classic, what was it, the Osborne problem, where they announced the new model and then sales of the old model tanked. The yeah, so target price of $1.50 per 8 I/O pins. Now this does not give proper DAC. That's the thing. But something like an RP2040 would be an alternative to this. So that is, yeah, anyway, lots of possibilities. This was also one of the reasons that I wanted to modularize the I/O portion of Testomatic, so that yeah, this I/O module can be swapped out if you've got specific needs, or if in the future we come up with a different I/O module that has other capabilities, then we can design a new module that fits into that same footprint, and that could be a serial Wombat chip, it could be an RP2040 on there, whatever. Doesn't really matter. Oh, Austin said, we'll use an ESP32S3 and the USB on it for emulation. Ooh, yeah, so many possibilities. This is the thing, is that this little footprint, also I have been thinking, Scott says, yeah, ESP32S3 module for testing ESP32S3 boards. Stephen W says, would a 2040 even fit? I think it probably would. Where are the dimensions here? So it's 12 millimeters. That is 2. So in between there is 8 millimeters. We've got 8 millimeters RP2040 dimensions. Where is it? Specifications. What is the? Come on, give me physical size. Data sheet. Hardware design. Yeah, let's try this. What does hardware design tell us? Footprint. I should no. Yeah. Come on, mechanical documentation release history. Where is it? AWM. Supported flash chips. No, I want the PCB footprint. 7 by 7 millimeter, says Sion. Ah, thanks, Sion. Oh, speaking of, Tom and I visited Sion and stole his IN6 reflow oven. So it's currently sitting in the cleanish room, back up on its stand. I haven't yet turned it on, but it is here. In the Google Pixel is a good photo. Yeah, so 7 by 7 millimeters, which means it should fit into this space here. Routing would be tight.
Henrik Ostrov said, in the Google Pix there was a good photo.
Yeah. Routing would be tight, but you could do it. So that is a possibility. You'd need to load code onto it, of course, so we'd need some way of programming it. Maybe with pogo pins on the bottom, don't know. Anyway, something you can buy that is cheap and has spares. Yes. Needs increase on lots of passives. Oh, right, yeah, that's true. So it would be, it doesn't need that many passives, does it? I feel like probably better with an AT Tiny. Yeah. For me,
Unexpected Maker said, needs external flash and external and lots of passives.
Yeah. How big is the RP2350? RP23, which I don't think you can buy yet. Oh, hang on, what? On AliExpress you can buy it. I've been trying to find, oh, see, on says 7 passives, I think. Is it that many? It's a while since I've done an RP2040 layout. Oh, 2350 is bigger. Okay. Anyway. So a possibility would be to put surface mount pins on the bottom, and then there is a whole 12 millimeters of width. So there'd be a bigger surface area here. You'd have limitations of wires and stuff to work around the pins underneath, but anyway, yeah. Put it on a hat, says Don S. Yeah, we could make it vertical. We could have a module that goes in and then another PCB that goes vertically into it. 2 for crystal, loading caps, 2 for flash, and 3 for RP. Right, okay. Cool. So 7 passives, Sion. Yep.
Scott Miller said, 0201 passives.
No, wash out your mouth, Scott. I'm not putting 0201s on it. Just to make the module longer if needed too. Yeah, so the module could be longer. It could come up here somewhere. I'd like to keep it within that footprint if possible, but there would be workarounds if necessary. It could even be double stacked and things. Yeah, oxtail. Just auto correction. I mentally corrected the auto correction when I read the comment. I saw that it said oxtail and I read it as crystal. I knew what you meant. So, okay, since Xeon is here. Okay, so that is enough on Testomatic, I believe. Let me find something else. Because, where are we? Where are we? Here. This. Okay. This is now in the cleanish room. Ta-da! You can see Bernie Boy 7000 in the background, and this is Xeon's Neoden IN6 oven in the foreground. The Neoden is so small. Such a small thing.
Steve Steph.
Steve Steph? No. No. Denied, Scott. Testomatic update over. Yes. Testomatic out. I will return to Testomatic because it is a very important thing to me. But I'm kind of gated right now on... I need to paint it red. No, I'm not going to paint it red. The rest of the... It's going to fit in a lot better with the rest of the room now. You can see in the background there, look at the KO. It's got that, you know, the classic sort of just slightly off-white with black and stuff colouring. And then the stands for the KO. Hang on, I'm going to see if I can find some. I'm in my pictures directory scrolling back. I'm not going to show this directly on screen because who knows what's in here. All sorts of things are in here. Where? It's got to be a recentish photo of the cleanish room. Okay, here. This is a recentish photo of the cleanish room. And you can see, yeah, at the moment there's just this trestle table with the it's got a static dissipative. That grey surface is static dissipative material, so it's carbon impregnated underneath.
Henrik Ostrov said, AliExpress sells RP2050 controllers all over and all their clones.
That's weird. Yeah, it's strange what you can find on AliExpress before you can even buy it from anywhere else. Last time I checked, you could not buy an RP2350 from anywhere. I think they were seeded to board makers, so there were a few boards that have come out already with the 2350 on it, but you can't just buy the chip yet. Maybe that's changed now. Yeah, so this now has an earth strap going to it, and that surface is a static dissipative surface. Got the machines here, so the thing that really looks out of place and old-fashioned is the Bernie Boy. It's definitely out of place. So this is much more in keeping with the aesthetic of the room anyway. And now I've got to get the conveyor belts working, it's already nearly 11 o'clock. And that was the whole point of the stream today. So closing. All right, who else has arrived? I'm just gonna, even though I've been talking to you already. Austin, Unexpected Maker is here. Jack's Tech, Greg DeVille is here. The Lane, some call it fun. Yep, welcome to the chat. So can you fit the extra PNP? I don't really want to.
Austin's_creations said, with the size change of the oven, can you fit the extra PNP?
I maybe could, but Yeah, I think it would be too much. It'd be very jam tight at the end of the room because the amount that the Iron 6 is shorter. Like the space saved by the Iron 6 compared to my current oven is not the length of a pick and place machine. It has saved a little bit of length, but it hasn't saved a machine's worth of length, which means that the line would end up jammed up even tighter against the end wall than it is already. So I would kind of like to get that third machine on the line, but at the moment I'm not even using the second machine because I need the conveyor belt to do the auto handoff between the machines, and it's right here and it's in pieces. We've got to fix that. What else? Oh, yes. See, I told you that this would not be a totally focused thing. I'm going to go to LinkedIn because I want to show you something. Where are we? Where is Kathy's post? Kathy, where? So this is something, this is, send everything you say. Here we go. I'm going to pull this up and show you this. So this is Kathy's post that she put up yesterday, and it is about changes to the way Amazon Alexa is going to handle voice processing. I said the word and it woke up, but it didn't do anything. Hang on, I have to cough and take a drink. Okay. John might say, oh, interesting. Amanda, I don't think I've seen you in the chat yet, Amanda. In the first hour, I have airbrushed and clear coated a prop gun for an upcoming short film I am the DOP and editor for. Oh, nice work, Amanda. See, Amanda is getting stuff done while I am sitting here talking crap. Stephen W. John might set the factory on fire and walk away if you forced him down there, Scott. What was Scott saying? Just looking at this. Scott says, just looking at the size chart, thinking 02005 would make John say backwards. No, I just refuse to recognize their existence. It's no. How do you even put the solder paste on? It puts the solder paste on, or it gets the hose. Oh, the jobs of that. What? Yeah. It puts the solder paste on, or it gets the hose. How do you put solder paste on a pad for an 02005 part? But yes, as Scott says, yeah, Greg says, if you can't see them, they don't exist.
Scott Miller said, very, very carefully.
Yeah. I'm, like, seriously, my comfort level, the sort of, oh, parts come pre-applied, yeah. Jack's Tech Solution. Yeah, you don't put on the solder paste, and you don't put the parts on, you just get the parts pre-applied. Yeah, that's right. I'll have my parts already on the board, please, where I want them. So for me, the super comfortable, can do it all day size is 0603. And at that size I can, Henrik, thank you for getting me back on track. So 0603 is like, you know, kindergarten novelty size that is...
Henrik Ostrov said, so what is changed on A_L_E_X_or_?
Yeah, we will get to that voice assistant who shall not be named. Yeah, 0603, put it down all day, no problem. Easy to deal with, easy to rework, do it all with a soldering iron, no problem. 0402, not really much of a problem. Getting below 0402, I have done stuff smaller than that, but it just turns into a bit of a pain. It gets down to the point where you're using like T5 solder paste and you've only got a couple of balls on a pad by the time you get down to the really small stuff. I think I've complained before when I was doing the... Which one was this for? I think it might have been for the CSIRO satellite project for Cyanosat 2. There was a tuned circuit on it that has programmable capacitors, and the capacitors have 4 pads under them, and the entire capacitor is... What was the size of it? It was like 0.45 millimeters square, I think, with like 0.45 by 0.45.
Alexa. Scott Miller said,
It did.
Hand soldered 0402. One day, you'll try 0201, maybe.
I'm not quite sure how to help you with that.
You woke her up. You worked around it. Henrik has found an exploit to get around the TTS limitations on waking up my voice assistant. Yeah, so yeah, 0201. That's not. Yeah, that's fine. I can do 0201 as well. But yeah, once you get down into the parts like these programmable capacitors, it's like almost like a BGA, but the entire body is 0.45 by 0.45 millimeters. And getting the solder paste onto the pads appropriately, everything has to be perfect. If it's not, you know, the right consistency of the paste, the right temperature, the right pressure, if your stencil is not perfectly clean, you don't get release from the stencil apertures. Yeah, you've got to have everything go right, or it doesn't work. It's annoying and fiddly, and I don't like it. So, anyway, the point is, Kathy posted about this article, and the article itself I read, and it's a little bit weird. Hang on, I'm gonna chuck this article into the chat, and privacy changes. So I read this article this morning and it confused me. So if someone wants to read it and clarify, that would be good, because what they're talking about is changing to using LLMs for the speech recognition side of She Who Shall Not Be Named, and they want it, and they're going to be doing that by continuously sending audio from the device. And so Scott says, suspect that applying solder paste for 01005 involves picking single solder balls out of the paste. Yeah, that's pretty much it. The problem is that at that size, surface tension is weird. Manipulating things at that size is very odd. It's like the rules change. You can't just pick things up and move them. You can't use surface tension to pick things up and then wipe it off onto something else. So in the move to use LLMs for the speech recognition part of the service, the idea is that, where is it? Starting on March 28, recordings of everything, and also some of the wording of this article, I have trouble reading it. It's like my brain misfires and I don't quite parse it properly. So it says, recordings of everything commands spoken to the Alexa living in Echo speakers and smart displays will automatically be sent to Amazon and processed in the cloud. Yeah, it's I mean, that sentence barely makes sense. So does that mean that it is all audio that is picked up is going to be sent to their cloud service for the speech recognition part? And does that mean that they are no longer doing local wake word recognition? And in this article, it also talks about the Alexa Plus service and the differentiation between regular Alexa and Alexa Plus. And if you pay for the extra service, like if you pay for that tier of service, then you get a whole lot of extra stuff. And the extra services are reliant on the use of LLMs in the back end, which can't run locally. They have to run on they have to run in the data center, which means they push continuous audio to their data center. And for various reasons, I don't like that. I have, as you very well know, everything in this lab is voice controlled. Every single PowerPoint is connected to the automation system. It was written by AI, says Paul Schultz. No, the thing is that I actually think this article was not written by AI because of the grammatical problems in it. So it's got a byline here. So Sharon Harding wrote it, who I assume is a real person. I don't know, but yeah, if this was written by AI, it wouldn't have sentences like this in it. So I actually think this is a real article. It's an article written by a real person. So yeah, a feature known as Alexa Voice ID. So this is to be able to differentiate between different people. If you have multiple people in a household, the system should be able to determine who is speaking to it, not just recognize the words, but recognize who is saying those words. So
Scott Miller said, the time has come to create a superhouse data center project for local AI.
hang on, isn't that contradictory? If we create a superhouse data center project, it wouldn't be local anymore unless you local voice recognition is good enough yet. I don't know. Some call it fun's question will come through in a second. I've just turned the volume up on the TTS because it wasn't particularly loud. Here it comes.
Some Call It Fun said, do you know if the local voice recognition in Home Assistant good enough yet?
No, I do not know. That is something that I want to investigate. And part of the point of bringing this up, of highlighting this situation, is that...
Amanda Thompson said, John, time you make your own local voice assistant.
Yeah, I know. I've already done some of that. In fact, so Kathy, who many of you may well know, is... so
Scott Miller said, data center as a local device.
Data center as a local device. So, Kathy, stretching. I've known Kathy for
Austin's
a very long time.
Said, Home Assistant in Paul Hibbert voice.
And for a while she worked at, I've gone blank on it now. There was that AI voice assistant company, the open source one, that started off as a Kickstarter and then it ended up failing. And I have one of them here. I have one of the early prototypes here. And so anyway, it was Raspberry Pi based, and they went through a whole lot of different systems for doing the speech processing. Henrik is doing it again.
Hey Alexa, what's in the news?
I have hit the mute button because I was saying that word myself so often. I have muted my Alexa. Sorry, you can't. You can't trigger it. Jordan said, the Home Assistant voice recognition depends heavily on the hardware in use, but it can be really good. Simon, has local kangaroos? I have two that have moved into my yard. Oh, cool. Mycroft, yes, that's it. Gerald42, thank you. It was Mycroft AI, yes. So Kathy worked at Mycroft AI for a while. and that was before she went off to do her PhD in AI. So, hang on, got a cough again. So, right, she worked at Mycroft, and the whole point of Mycroft was a privacy-aware voice assistant. And I am really, really sad that that did not work out. It would have been nice to see a privacy-oriented voice assistant which you could run on local hardware and have full control of the stack if you wanted to. Yeah. But now, because of this, I'm in the situation, so what is it, March 16th now. We have 12 days, people, 12 days to figure out whether we want to turn off our Alexas and never turn them back on again. Because it's going to be, yeah. One thing that many years ago, so while Kathy was working at Mycroft, when they were doing training, they had a number of beta units out in the field. And one of the things that they would allow you to do is you could opt in, so it wasn't turned on by default, but you could opt in to allow your commands, like your interactions with the voice assistant, to be used for tuning purposes. And what that meant was that those, when you talk to it, it would be recorded and then it would be sent to Mycroft, and their engineers would go through the recordings and they would check, for example, what is the success rate, like what is the positive recognition rate, what is the failure rate on recognition, and then tune it to deal with different accents and different speech patterns and all of those sorts of things. And the things that were being picked up in those recordings was scary, because when you are talking to your voice assistant, there could be conversations going on in the background in the room. And the recordings that the voice assistant makes, because it's like a rolling window, what happens is that it will, when you trigger on the wake word, it will store a couple of seconds of audio from before the wake word, and then the duration of whatever is required on the utterance that you are making. So you might end up with a 5 or 8 second audio clip, and that can include things like conversations in the background, people just talking about other things. It'll be background noise, it'll be whatever is on the radio or on the TV, it'll be, yeah, lots of stuff. And it is surprising how much privacy is leaked unexpectedly. Just to mess with it. Some call it fun. Perfect use for CQ. Don says, Dr. Mike from Mycroft now works for Home Assistant. That's interesting. Initiate manual rickroll. Phrase to text recognition. Keith said, can you put your Alexa on a smart switch and just turn it on whenever you want to use it? Scott says, Alexa, turn on Alexa. Damn it. Yeah, so you need some kind of a local wake word type mechanism. One thing I've been doing is using my watch. I have Alexa set up on my Fitbit, but it's not always listening. It only listens if you press and hold the side button for a moment. But it's really convenient because I can be walking around the factory, and I'll unlock it now. If I press it, first thing is it's going to want to unlock. I'll do that where you can't see it. All right, so now my now my Fitbit is unlocked, but I can do things. I don't even need to say the wake word because it's done by the long press. So I'll just do a long press, turn off the office lights, and it happens. So this is really convenient. Turn on the office lights. Is it going to? Yes, it is. So that is convenient. Even if I turn off my echoes, because I've got a couple of Amazon echoes here. There's one on my desk, there's another one in the clean room. So even if I permanently mute those, I will probably continue using the Alexa via the watch, because it's just a convenient way to do it, and it is not continuously listening. At least I don't think it is. Right, where are we? We're at 10 past 11 and I have not got to the conveyor. But I suppose every now and then you've got to do some catching up. So yeah, that is the news, the sad news that Kathy posted about yesterday. It's sad, but not unexpected. I mean, these companies are always out to maximize profits, and they want to be able to generate revenue from their products, ongoing revenue, not just selling the item and then supporting the software forever, which effectively is the situation that they are in. Like if they sell you an Echo, which you put on your desk or in your kitchen or whatever, they have to keep running the back end of that forever in order for that device to keep working. So they've made money on you by selling you the device, but then their costs are incurred on an ongoing basis. Got a cough again.
Shall not be named over Google.
Yeah. Say what? Says Pete.
Pete said,
Yeah, it doesn't. It does not recognize that. The TTS did not handle that very well at all. Yeah, so. Oh, new version of Java is available. Go away. Go away, Java. Okay. I don't think I'm going to get much done on this conveyor belt today, am I? Not really. So I'm going to, where are we? Superhouse projects, conveyor. What I'll do is show you what I have been up to. Conveyor assembly. There, frame. Frame assembly 2. I'll get this up where you can see it. And maximize. So we've got, these are all the different parts for
Henrik
the...
Ostrov said, I asked why you use who shall not be named, but not the Google think.
Oh, don't know. There were, at the time, I don't think there was any particular advantage one way or the other. And I just got one. It might have been on sale or something. Don't know. It was years ago. And all these different parts. Okay, so these are all the different URC. Why is that in there? I don't know. There's the time of flight module. Blah, 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 blah. Conveyor assembly. Conveyor assemble.
Pete said,
yes.
I've been learning Urdu for work. Have decided I only need 3 phrases. Thanks, I need a tool name, and no.
Oh, learning Urdu. That's interesting. Yeah, so this is my model. Some of the things aren't accurate. For example, the linear rail. I just grabbed a linear rail model off. Where was it? I don't remember. Probably GrabCAD. And it was short. The actual linear rails run almost the length of this top rail. They're 300 millimeters long or so. I can't remember the exact length. But this is the basic structure of the conveyor, minus a few things. But this is quite an old model. When is this one from? Oh, it says 1st of the 2nd, 2025, but that would have been, yeah, I don't even know why it's got that update date. I might have saved it just because I'd hidden or shown different elements. So this, and this is not a complete assembly because there is the housing over this. This is a very simplified version of the chassis assembly. there are many parts involved. So let's go to this view. And I'll show you what I put together yesterday. It's a bit hard. This overhead camera, I've zoomed it out in preparation as far as it can go, but this is as zoomed out as it goes. So we've got these linear rails are not yet attached, they're just sitting there, so that's one of my jobs, is I still need to attach the linear rails. So I've got the base frame. In fact, I'm going to take those off, otherwise I'm going to drop them and it'll be sadness. This is the controller, the current version of it, the most recent version. Here is the chassis. So we've got the back. This is the back of the chassis with the homing switch. This is a couple of 3D printed parts that integrate together. They screw together so that it fits on top of the frame. It screws into the frame under here. You can see a couple of M3 bolts there. The two parts screw together. Then this is an optical switch. The cable goes down through the frame. And part of what I've tried to do here is conceal the cabling as much as I can. So the cable for this switch goes down inside the frame, travels around there through that corner joint, comes along here, it travels around that corner joint, comes along here, and then it comes out here. So that is the connector that goes all the way back to the homing switch. And that's just a cover that goes over it. So that drops on, and there is a slot exposed there. So when the top part of the frame, which goes like that, moves to the back, it'll have a little thing sticking off here, which goes into that, and that's how it sets its home point. And then the calibration tells it what the offset is relative to the front rail. Then, at the front part, it really is hard with this camera. I need an alternative way to do this. So the front part, this bottom frame is a basic rectangle. If I turn it right over, yeah, you can see it's a basic rectangle. I've put little rubber feet on the corners here, and there is a whole lot of wiring that runs around inside this frame. This is one of those little 28B stepper motors. What is it? 28B YJ48s, the super common 5-volt stepper motors. Inside a housing, it's got adjustment on it so that it can move backwards and forwards, because this GT2 timing belt goes around that little 3D printed gear, and it will go into it goes around a little runner with a bearing that goes into this. I haven't put it in there, but there is like a runner on this end. An M6, M5? M6, I can't remember. No, I think it's M5 bolt goes through, and then there is a bearing that goes on it, and then there's a 3D printed thingamajigamy. Those are all over. I've printed them, but I just haven't put them on this particular chassis. So that stepper, this stepper here, can rotate this timing belt, and the cross piece here attaches to one side of this timing belt, so that as the stepper turns, this cross piece moves backwards and forwards like this. And that is how the width of the conveyor is set.
Pete said, time for bed.
Time for bed? Yes. Yes. Time to go and snuggle up in bed. All cozy and warm. And listen to the rain. That's what I should be doing. So then, at the front end, we've got all of this stuff coming out. And this is what I want to mess around with today. What is the time? 11:19. Okay, I think there's still time. Oh, my heart rate's elevated. 73, 74, 75. My heart rate's going up. 73. Yeah, so we've got these 3 ribbon cables coming out. Those go to the PCB sensors. You can see these things here. These are time of flight sensors that are looking straight up. So we've got one on the left, one in the middle, which is slightly offset because it can't be right where the thing is, And in fact, being offset more might even be beneficial.
Time for bread.
Time for bread. And one on the end. So this, if we are talking about a left to right conveyor, I'll put the conveyor in this orientation. This is how I would normally use it. Production lines are typically set up
when it passes 100.
are typically set to be in either left to right or right to left mode, obviously. And the most common for surface mount assembly is left to right mode, where if you consider the front of the machine to be here, this side here, then the product, or whatever it is that's being moved, goes from left to right. So this is the entry side here, exit side over here, and that would be the back of the conveyor belt. So if I put that right there, imagine that we had a PCB like, oh look, here's one I prepared earlier. Here's a rack 32. Imagine this PCB is traveling along the conveyor belt. What it does is you adjust the width of the conveyor belt so that this just sits on it nicely, and then it so as it enters, this time of flight sensor, which is looking straight up, detects that the board has entered, and then as it travels along, this sensor will detect when it has reached the midpoint, so that would trip there, and then this sensor detects when something has got to the exit point. And if you are exiting, say you're moving a PCB along the conveyor.
Fun said, what did I miss? Why so many ribbon cables?
I will get to the ribbon cables. That's actually the main thing today. So we will get to that. So if you are exiting a board from the conveyor, it's kind of falling down. The reason is that this is lower than this because it's meant to be up on the linear rails. So this back should be elevated. Not that you can really see that on screen because you're looking straight down at it. But this is currently sitting too low. So if you send the command to exit a board from the conveyor, it needs to be able to detect when it has reached the exit point, just there, so that if you move a board up and then the next machine in the chain is not yet ready to accept it, it needs to hold the board at that position. And then when it is ready, when the next machine is ready to accept the board, have it go active again, start moving the conveyor, move the board off, and then it needs to detect when the board has completely cleared, like it needs to know when the board has cleared the conveyor, and that sensor will also tell it that information. So the exit sensor is a very important one. Probably the most important sensor in the system. And these are time of flight sensors. In fact, I'm going to go and grab, what am I going to get? Oh, I've got things, where are they? Over here somewhere. Here's one I assembled earlier. I've got to grab that. And I'll show you what these time of flight sensors are doing. So this is the very old, this is the first generation conveyor controller. So this is the new one. I'm going to take that sensor off. We'll get back to that. So first gen here, second gen here. And as you can see, the layout has been changed fairly radically because I went from using step stick style modules to using DC motor control there. And that is an H-bridge, so that we can run the motors at different speeds, etc. But they're just DC motors. And it's gone from 2 sensor inputs with these IDC connectors to 3 sensor inputs to correspond with the 3 sensors here. Because originally I was just going to have entry and exit sensors, and then I realized that it'd be useful to have some midpoint sensor as well. So I added the 3rd sensor for the midpoint, and then we've got CAN bus connections on both sides. There's a CAN controller, what is that one? I think that's the CAN transceiver. Yeah, optos for ready in, ready out for communicating with other machines. Anyway, let's put that aside for now. So these time of flight sensors, this is inside a little 3D printed enclosure. It's got an IDC cable on it coming out to an IDC 6 header. And this design, you can see it's got a little notch in it. If I move it to here, in fact, you can probably see this better in CAD. Let's have a look at that. Where is the TOF enclosure? Oh, this one's a fun one. I'm just going to open this one. So this is the mount. So this thing here, if we spin it around this way, is a kind of complex looking shape. It's got like a chamfer around there and different mounting holes and things. And this is the cover for it, the limit switch cover. Looking at it upside down, so it goes that way. Now back to the limit switch mount. That combines with somewhere here. Oh, the y-axis idler clevis. So the y-axis idler clevis is this thing. So that combined with that, screws into those little holes there, is that. That's the cover that we were just looking at. And it's designed so that you can either use one of these optical sensors, or you can mount just a regular micro switch. So a mechanical switch. It's got the holes in here to mount the micro switch there, and then the cable goes down under the switch body and comes through. So they work in exactly the same way. You can do it with either the optical sensor or the micro switch, depending on what's available, and the plastics are the same. And that's the y-axis idler clevis on the front of it, where the y-axis idler wheel mounts. Now back to here. Yeah, so that's the mount for the optical sensor. Now what I was looking for, oh, here's the time of flight module. Okay, so this is a very crude 3D model of the time of flight sensor. I made this just to have some placeholder for when I was working on the enclosure. Where is the time of flight, the limit switch? I can't see it here. Maybe those parts were saved elsewhere. I need to be able to find them. Carriage plate hole. Oh, sensor housing. Okay. This is it. There should be a couple of bodies here. Oop. Body. Why is that not visible? Oh, there we go. Okay. So this is the housing for that time of flight sensor, and it's made in two parts. It's got that cover, and this is where the sensor is visible. The reason there is a recess there is that there are solder joints that need clearance, and the PCB pushes up flat against this surface with the time of flight sensor protruding through that hole, and then the IDC cable comes up through this hole, and that's the bottom that goes on it. Now what is going, oh, cover, okay. Yeah, and this is the bottom. You can see the PCB fits into there. That is the PCB for the time of flight sensor. And it fits into that cavity there with the IDC cable running through this cavity in the bottom and then coming up through that hole. And it's got mounting holes that go all the way through it to go onto the frame. It's a little bit hard to see when it's all printed in black, but this is it. And the time of flight sensor is there. Connector comes up here and plugs into the controller. And the thickness there, the reason that there is this little recess, the thickness of the enclosure at that point is the exact thickness, the distance between these two layers of the frame. Hang on. Oh, not sounding good today. And the thickness there is determined by the thickness of the linear rails. So the thickness of the linear rails with the carriage is the thickness of the sensor housing at exactly that point, because it goes in that cavity between the two things. So that it can then point up like this. So it protrudes out and then it looks up directly beside the conveyor, because ultimately there will be a belt here that the PCB will rest on and that will rotate, and that's what moves the PCB. So what I need to do now is, so yeah, anyway, yesterday I got the chassis to this point. I still need to put the linear rails on, but I've got all of the wires hanging out. This wire is, there's another 3D printed part that goes in here. There's a DC motor, and that's what turns the conveyor. So this is the wire to the DC motor. This wire is for the other DC motor, and this will go through a micro drag chain that comes up to the top, so that as the conveyor moves backwards and forwards, this wire in the drag chain just moves like that. And those two come out here. So these are the two motor lines. These are the three board sensors. This is the stepper motor here for the y-axis movement, and that is the limit switch for homing the y-axis. So everything that we need to control is here. It's all coming out on this front part. So there is actually a lot of wire in this. It looks really simple. It doesn't look like there's much to it. And when this is inside the drag chain, and when this is concealed, you're going to see 0 wires, essentially. It's all going to be enclosed, and the whole design will look really super clean. But there is all of this cable going on inside the frame doing things. So one of the next things I need to do is to design an enclosure for this, which will sit right here, and all of these things will plug into the back of it. So I need an enclosure that is going to have a cavity on the front where the screen is visible. This is a touch screen, and that will mount onto the frame back on here with all of these wires connected. So one of the next things I need to do is figure out the state of this controller, because it's a long time since I've looked at this design and figured out what was going on. I know that there are some things that I want to improve on it already. There is this patch wire. I want to change the footprint here. This connector is for the limit switch, which is this. And the order of the pins on here does not match the order of the pins here, which is fine if you're just putting a pin header on there and then you ordered these appropriately, but it's prone to error because you've got to change the order of these wires and then plug them in. What I want to do is replace this with a JST XH connector, because, like one of these, because the other end of this cable actually has a JST XH connector on it that goes into the sensor PCB, and what I want to do is exactly match the pin out here as at the other end, so that it's just a direct XH cable. And then this, so I need to move a couple of things, make some room. The CAN termination resistor right there is getting in the way, so I want to put that connector there, and that is going, but with the pin out switched. I can't just solder this in now because the pin out is wrong. So I want to change that to make it have the correct pin out and room for the XH connector. So there are definitely improvements that need to be made to this design, but what we have here right now is enough to validate the rest of it. So I need to put some IDC headers on here. I need to plug this in, connect it to USB. I need to bring up the firmware for it and figure out what the hell I was up to. What was I doing? What was I thinking? I do not know. Actually, is that a, no, that's not a, I don't think that is the CAN controller. I think that is, because I was using the onboard CAN controller out of the ESP. I think that is an I/O expander. Maybe? Yeah, I think it's an MCB 23017. But in the little SOIC footprint, not the TSSOP or whatever it is that I normally use. Or the other way around, I can't remember. So I need this. I need to put plugs on these, plug them in, power this up, and see what happens. See if we can read from these limit sensors. Now, I have not yet figured out, oh, and also I've been starting to take notes. So this is my lab notebook for the PCB conveyor project, and as I've been starting to assemble this, I have been making notes of things like cables and the cut lengths for the cables. So this is for the limit switch, the one that goes all the way around to the back. But also I have, where are we? Sensor wiring. Yeah, okay, so I started yesterday making a record of the length that I cut the cables to. So for the left, middle and right sensors, the IDC cable, these are the lengths that I cut it to, and now I have it coming out of here. I can see whether that is reasonable. So that's the right, the middle and the left. It looks like the middle is a little bit long, so I could reduce that by 20 millimeters or so if I wanted to make them all the same length, and then it should plug in neatly into here. So in fact, I'm going to make a note of that right now before I forget it. So which one was too long? Middle. Okay, so middle could be reduced, could make it 200 millimeters instead. Reduced to 200 question mark, just because it is currently coming out longer than the others. And I haven't got to the stage of figuring out what the orientation should be, like what is the actual cable routing. At this point it probably doesn't matter. I'll just crimp the cables on and figure it out. So pin 1 is down in all cases, so I want it to go that way or that way. That one is fine, and this one can, yeah, that's doable. Alright, so I've got left, oh, and here I've got right, middle, left. Here I've got right. It seems counterintuitive, but because of the way the cable runs, it comes through the frame and then out. We end up with the left connector on the right connector on the left side and the left connector on the right side and the middle in the middle. So I need to bend the cables around to make them go to the right places. So cable time, I guess it's crimper cable time. Let's do crimper cable. Crimp, if I do that and then it goes around. Sorry, I'm just thinking through where the cable routing is going to go. Where are my pliers? Where are them? Oh, I know where the maxi pliers are. I need some parallel jaw pliers for doing this, but I don't have any, so I'm going to bodgy them. I'm going to bodgy it just with regular pliers and try to grip it in such a way that it's going to put linear force on it. Yep, that way, and then this one that way. But I'm going to take, I will take 20 millimeters off this one just to see, just to make sure. Get out the old industrial scissors. Take about, take about 20 millimeters off. So that's middle. I'm going to be covering the label on this one, but the other two are labeled, so by elimination we know that's the middle. And then this one, I need to what I need is to accumulate a full bill of materials for all the parts for this. This is a little bit of a test run, and oh, did that click into place properly? I didn't really hear it go clunk. Oh well. Alright, so I'm still in the process of kind of doing these on an ad hoc basis. This is only the second of these conveyors that I've assembled, and I'm just kind of making it up as I go, but I need to be creating assembly documents as well. It shows how everything works. My seat is sinking. There we go. I need to replace the gas cylinder in it. So now, what am I going to do? Right. So that's right. It's fallen back into its natural position. So I want, that one's left. So it's left, middle, right. And I can't remember if I can power this off USB or if I'm going to need to plug something in on the CAN bus connection, which is how it gets its higher voltage for running everything. The plan with this is to pass 12 volts down the CAN bus. So I'm going to plug in USB, and then we're going to jump into, where's the socket? There it is. Then we're going to jump into Arduino, and I'm going to cry when I see whatever code I did for this last time, and we'll see if we can make it actually do something useful. Plugged in there, back to here. Oh, hang on, back to here. Look at this. PCB Conveyor V2.0 is upside down for me as well. So where is it? Commands, command to blah, blah, blah. It's got MQTT 192.168.1248. It's come up on my network, and presumably it's connected to MQTT. So it's doing something useful. Maybe, perhaps. Is anybody still here? I haven't been... I don't even know where the chat has gone. Where is it on my screen? Where is it? Oh, that's right. It's behind Fusion, isn't it? It's up here. Yes, there are still people here. You have boxes and boxes of notepads from projects, ideas and plans? Yes, I do. Yes, I do. So I've talked about this before. My organizational process is to encapsulate my notes for each project with the physical artifacts of the project. So, for example, this is my box for the PCB Conveyor project.
We all dozed off.
Good to know someone did. Yeah, this is my box for the PCB Conveyor project, and in this it has all of the things you would expect, the random parts and PCBs and stuff, and a notebook dedicated to that project goes in the box. So when I pull this box out, I have all of my lab notes and calculations and schematics and measurements and pinout diagrams. It's all self-contained within this, so I don't have to go hunting around for where are the notes for that particular thing. I can switch into the context of working on this project, and everything is there. I do that for my clients as well. So, and that keeps a kind of firewalling, so that still nearly 60 of us. Cool. Keith said, geez, when you plugged in the USB, my house power reset itself. Yeah. Alan Madsen has arrived. Hello, Alan. Oh, okay, so a few people have arrived in the chat since I've paid attention. Espro Kelly is here. Pete is here. Keith H. Amanda. I already said hello to Amanda. Johnny Bergdahl. And Alan Madsen. Thank you all for coming in. Air gap firewall. Yeah, that's right, says Don S. My client projects, in fact, you can see behind me, If you see, whoops, that side, those red marks, the plastic tubs that have red on them mean that they are client related. And the reason for red is danger. It means don't show this publicly, basically. It's the yellow ones that you can see down here, those are project boxes. I can't read it in the camera. Oh, ESP1SH and Rack 32. So that box right there that I'm pointing to, that is the Rack 32 project box. So inside that are Rack 32 prototypes and bits and pieces, and there will be a notebook specifically for the Rack 32 in there. Yeah, yeah, Will Robinson, danger. Yes, so then, yeah, it means that if I've got a whole lot of notes in relation to one client, and I pull out that client's documentation and parts and everything, it's isolated. There is no danger that I will be talking to one client and I will have information about a different client's stuff there. Shall we get a curtain for the LED? Yeah. No, the labels are okay.
Some Call It Fun said, should you get a curtain for the red rack to hide labels too?
No, I think that's okay. Now, where am I going? Okay, I'm going to open projects, conveyor, PCB, conveyor, firmware, and this is what we are up to, PCB conveyor 2. I think that's the most recent one. Yes, I really should have stayed snuggled up in bed. Ah, hang on. I got to do this again. Okay, so modification dates. 4th of February 2024. That's the most recent. It's a year plus ago. A year and almost 2 months ago. Month and a half. So that is the most recent version of the firmware. Where was that limit test? Oh, VL. This is the time of flight sensor. VL53 time of flight sensor. That was from January 2022. 3+ years ago, I was working on those PCB sensors. Ah, yeah, I get through things so quickly. Hang on, I got it. Oops. It's opening now. And I had a sudden horrible thought that I could dox myself and reveal like Wi-Fi details and things. So I'm just going to have a look in my config. Does it? Limit position, PSK. No, it does not. Oh, hang on. Shh, secret. Ah, here we go. Yeah, I think it might have been from this project that I doxed myself at some point. You know, does it include secret? Yes, it does. Okay, cool. I'll just remember not to go to that tab. So I should not click on this tab here, right there. I've got to resist the urge. So that is where the MQTT and Wi-Fi and all of that sort of stuff, auth credentials are located. So we've got the config file, which I can show you, and we've got the secret file. And now, this is going to be just a matter of me reminding myself what the hell is going on. And okay, minimum conveyor, maximum conveyor, so all the configs, speeds, limit back off. Okay, home switch offset, millimeters, okay, yep. Enable Wi-Fi and MQTT. This stuff is no longer in here because it's in the secret file. PWM frequency, pin 1, pin X in 1. What is pin X in? Oh, okay, no, this is for X-axis. So that's the, yeah, there's an H-bridge E type thing. Yep, okay, cool, got it. So these are the pins for the X-axis. Yeah, so this little part
Scott
of the
Miller
live
said,
stream.
separate WAP MQTT server for project testing.
Yeah,
Just a good idea.
yeah, that is definitely a good idea. I should do that. Will I do that? Maybe. But it's definitely a good idea, and I definitely should. So Y-axis stepper motor. It's got a 4-pin stepper driver. Pins are set there. Steps per revolution. Steps per millimeter. Yep. Okay. So that's a calibration value that I did previously. Limit sensor Y pin. There's only one. So 30. Oh, hang on. No. The Y-axis is the front to back movement. So that is the width of the conveyor. Ooh, nice. So we've got the PCB sensor addresses. We've got 3 of them set. We've got the X-shut values. That is a peculiarity of the time of flight sensors that I won't go into right now, but that's how we have multiple sensors on the all connected at the same time, that we enable them. The X-shut allows us to disable or enable each sensor and then assign it a new address, because when these time of flight sensors first power up, they always have the same address. They do not have address pins on them, so you have to configure them in firmware. You have to configure the I2C device over I2C, so it comes up at a known address, and then you tell it what its new address should be, and then it switches to that address. And so we have 3 of them coming up on the same address, and so what we do is we use the X-shut pin to shut it down. So we shut down 2 of them, we reconfigure one, it then moves to a new address, and then we enable another one, and then we reconfigure it and it moves to a new address, and then we enable the 3rd one. So that's the reason that we've got all of this weirdness going on here on the PCB sensors. CAN bus, using J1939 style messages. I think I can't even remember what my CAN bus parser stuff is here. Where is it? G-code motors, CAN comms. I think. What was I doing? Yeah, okay, so I implemented J1939 encoding on this, which is super simple. Like, what do you see on the screen here? This is the entire CAN bus message processor, because all it's doing is accepting the message, and in fact that is debugging, so you could even get rid of that. So what it is doing is just reading the message into the buffer, and then it is sending that buffer to the G-code processor, because the buffer is a global, and it's just stuffing the buffer and then calling off to process G-code message, which looks in the global. So what I should be doing probably is accumulating a buffer and then passing it as an argument, but hey, this is what it's doing. Ugly. So that is it. It is just blindly accepting the message in J9 from a source address, and yeah, passing it to the parser. So the G-code parser is here, and it is taking the message. I think maybe the reason that I was doing that is that the buffer could be populated either from, yeah, there is a design problem there. I need to make it so that the buffer is accumulated from the CAN bus and then passed in as an argument to the parser to process G-code message, rather than this relying on a global buffer which is set elsewhere. And it could be set either, so this is the serial stream, it's reading from the serial port, we can send a G-code via the serial port and then it just gets processed, or we can send G-code via CAN bus and then it gets processed. It's 2 input paths getting to the same destination. In either case, it gets to this G-code parser and just gets processed. So it's looking for a home command or a move command or whatever, and then doing the appropriate things. Spindle stop. Oh yeah, that's right. I was repurposing the spindle speed G-code to tell it how fast to move the conveyor, because I don't think there is a specific G-code command for conveyor speed, but I'm just treating it as the speed that you're spinning like if you've got a CNC machine with a spinning spindle, you tell it how fast you want it to spin. I am using that speed, like that rotational speed, as the command to set the speed for the conveyor. Spindle right, spindle left, spindle stop. Yep. All right. Or complain. So where is it dealing? Here we go. PCB sensors. So this is using the I/O expander for the X-shut pins. And what is it doing? Failed to initialize left, initialize left, initialize the left sensor, bring up the M sensor, bring up the R sensor. Why are they disabled? Maybe this is as far as I got. I might have been at this point last time getting the PCB sensors working. So bring up the middle sensor. Alright, well I suppose the thing to do is just to try connecting. I don't even remember what the board profile is for this. Where is it? ESP32, it is ESP32 dev module. Okay, so if we go to board type, yeah, I was working on an S3 most recently. So ESP32 Arduino, and we'll go to ESP32 dev module, and once it finishes doing its recalculating the world, we'll see if we've got a serial port that does nothing. Hopefully we do. Because what I want to... Oh, come on. Give me the menu. Here we go. Port. It'll be that one. Let's just open a console and see what it is reporting, if anything. Now, where is... Well, I'm just sticking my hand over the sensor and nothing is happening. But let's hit reset on this. Where is reset? Is there even a reset button on this? I can't remember. There might be a reset somewhere on the module. It's the WT32 SC01 module, I think. I can't see where the reset button is. Oh, hang on, that might be reset. There's stuff in the way, which means I can't actually see onto that board. There's a button, so I'm just going to press it and see what happens. Oh yeah, there we go. That was reset. Initialized left PCB sensor. And connecting. Okay. Initialized left PCB sensor, but presumably it is not reporting anything. So I don't even know if that sensor is working. Let's see if we've got any processing on it. What's the loop doing? So we've got setup. Yeah, a whole bunch of screen stuff we don't care about. In loop, we are set conveyor speed. We are not doing anything with checking the sensor. Okay, let's try. Where are the serial? No, sensors. PCB sensors. Debug sensor values. Okay. Sensor ranging error. Maybe I should just call debug sensor values somewhere in loop and see what happens. Disable all but L sensor. Initialize the L sensor. Is debug sensor values called from anywhere? I don't know. It's declared there. Oh, okay. It is in loop, but it was... Oh, and looks like read can messages is disabled as well. So let's just hit upload and see what happens. We may well get a stream of values coming back now from that sensor. Compiling. Now, where's the chat gone? Chat, oh chat, wherefore out there?
Fun said, check comments for Alan.
Okay, I will, but first I've got to find the chat. There it is, underneath all of these. Alan Madsen says, why aren't you using the f equals feed parameter, G0, X100, F200? Yes, that's an interesting way of thinking about it. I think the reason is that we are not feeding to a specific destination. I think that was my reasoning at the time. So, okay, so just to explain this, what Alan is suggesting, the context of this, I am using I'm using the spindle speed to set the movement speed of the conveyor. And what Alan is suggesting is that because the conveyor is moving left and right, it's a horizontal movement, that is essentially the x-axis. So if you move the conveyor from left to right, then you are moving positively in the x-axis. So you could use a G0 command, which is just a standard go command. So you could say go 0, like G0, X100, and then F200, F being the feed rate for how fast you want it to move, and it will move 100 millimeters from left to right at that feed rate. Okay, the difficulty with that is that this is a continuous movement. We're not setting a destination of where we want to move to. We are just telling it to start turning and keep turning until it has been told otherwise. Oh, look at that. Oh, look at that. That's me putting my hand over it. We got ranging error. That's with me putting my hand pretty close to it, and then I'll move it away, and you can see the millimeters go up. So it's reading 150, 160 millimeters. My hand is away from it. Lower it down, and the values get lower. I'll put my finger right down close to it. 20, yeah, it kind of bottoms out in the mid-teens region. It doesn't read down into the few millimeters region. But that is perfect. So that is reading what I would expect when a PCB, so if a PCB was above it, I'm just going to put something there at the height the PCB would be, it'd be about there. So it'd be reading somewhere in the 30-ish millimeters range, which is great. So we can set a threshold and we can just discover when there is a PCB there. So back to the feed thing. If I start the conveyor running, I do not want it to run for a while and then stop because it has reached its destination. So, or Jordan says you can use relative move. Yes, but, and Don says it's not a move absolute use case. Yeah. Oh, Alan, so your comment, I don't know if this was an intentional typo, but if not, if this was intentional, this is a classic comment. Don said, it's not a move, oh, where was it? Alan said, that's the right yaw to do it, which could be way mistyped, it's the right way to do it, or yaw is like lateral movement, and we're talking about lateral movement. Yes, Alan, I know, you meant to say way, but yaw is actually a funny pun because we are talking about yaw, like roll, pitch, and yaw. Roll, pitch, and yaw. So, no, yaw is that way, isn't it? Yeah, so, okay, so M3 S10,000 is a way to start a spindle and M5 stops it. Yeah. So that's the thing, is that whether it's a relative or an absolute move, I don't really care. I still do not think, I don't think that a go command on the x-axis is the correct thing to do to move the conveyor, because say I just want to turn the conveyor on and have it run. I want it to send it a command to move at, say, 1,000 millimeters per minute, and just set it to that constant speed and just keep running forever. Like I might want it to run at that speed all day. If I wanted to do that and use a G move, I would have to set some extremely large target distance. Like I would have to say G0 X 9999999999999 F F1000 or something like that, and hope that it never actually reached the destination of the move, because when it did, it would stop. And we don't want it to stop until we tell it to stop. So I think using the spindle speed as the conveyor speed is the best solution here. Ranging error. Yeah, so what I want to do is debug sensor values. Where are we? PCBL ranging test, blah, 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 blah. Let's try 1. What? Is it printing 1? I don't even remember. Yes, it is printing 1. Okay. So let's not have it print a ranging error. And oh, it is not equal to 4. So range status is 4, must be like a that must be the value that it returns if it is a bogus reading. All right, so G PCB reading L false. We could be really crude here, and well, actually no. What I'll I'm just pondering what to do. L, let's make it _M. Yes, I know. I am breaking the don't repeat yourself rule. Range status, and that is going to be sensor 2. So let's offset it by a bit. PCB L M, and so this should report the middle sensor reading. It'll be offset across the page. We're not yet initializing it, so let's do that to bring up the middle sensor. Failed to initialize. Okay, let's just compile it, send it, and see what happens, if it even compiles. You could just look for range status to see if there's something there, says Jordan. Some Call It Fun said, does the belt have limited slip in case limit sensor is ignored? Physical hardware for limit. No, it doesn't, and in fact it is going to be a fairly positive drive, because the way this works is I'm using these GT2 timing belts, which are ribbed. They've got little ridges along them, and the drive gear that engages with this has ribs and slots. So as the motor is turning, it turns the thing. It's not a friction engagement. It is a very positive engagement with the belt, and it would be quite
Unexpected Maker said, I want to see conveyor cam.
Conveyor cam. Ooh, it's working. Hang on. Look at this. Look at the, see that left? That is the left sensor as I move my hand over it, and then the middle sensor as I move my hand over it, and I'll move it up and move it down, so we can see the values coming back, which means let's go for broke and bring up the right sensor as well. Don't you love it when past you has done most of the work and then you can just take advantage of it? So here we go, breaching the don't repeat yourself rule again. And what are we doing here? Yeah, this is Arduino IDE is not a good IDE. So for doing things like refactoring, it's a bit of a pain in the ass. So this is going to be sensor 3. Let's offset it even more just to make it obvious. So we've got RR range, and we're initializing the right sensor. So go, upload, compile, clear that. So what did Sion say? You want to see conveyor cam? Bitcoin bars into ownership. Bitcoin bar. What the hell is a Bitcoin bar? Is that like, when you say bar, are you talking about a bar of Bitcoin, like a bar of gold? Or are you talking about a bar where people go to drink and discuss Bitcoin? That sounds like the world's saddest place. Okay, compiling, uploading, writing. Buy beer with Bitcoin. Oh, that's what it is. Oh, I can hear someone doing a burnout out there at the moment. The streets are all soaking wet right now, so yeah, you don't have to be much of a hero to do a burnout outside right now. Look, it's crashing. That's interesting. Backtrace. All right, rebooting. Why is it rebooting? I'm going to try just getting rid of that without changing any of the anything else. See if initializing that third sensor is what is doing that problem. I'm too lazy to run the backtrace through a decoder and then figure out what's going on. I might have to resort to that. Oh, hang on. Bring up the R sensor. That's why. This is why we gotta. This is why it is freaking out. So it was doing a second begin on that sensor object. So that is definitely going to make the thing explodify. Let's re-enable this. Yeah, so this is still going to explode once it finishes uploading. I'll wait till it finishes and then I'll upload it again because I've already made the fix. So yeah. Oh, hang on. Why is that working? That's the distance to the... Funny thing is, that is actually pointing to the distance on to the down camera. If I switch to the down camera now, you are so that sensor that is here is looking up at the up camera, at the down camera, and it is reading it as being 1.1 meters away, which is correct. But why didn't it crash? Oh, it was just the debug. No, that doesn't make sense. So we're still initializing, but maybe you can initialize it and then it's not being referenced, so therefore that's not crashing. Okay, let's fix this. Hopefully this will now work with all three sensors. And now where's the chat again? Oh, chat is up here. We can see the IR in the feed. Pete, I am home. I got no one to go home to. Why would I go home? Liquid horsepower skiddies for the kiddies, also F1 weekend in Melbourne. Oh, okay, yeah. Just use DLC 32 version 2.1 to control XYZ, and a laser motor uses standard G codes and has limit switches and so on. Okay. To control XYZ. Let's see what happens now. Uploading, connecting. Oh yeah, so sensor 3 is reading. Yeah, so sensor 3 is the one that is reading the distance to the camera. So that, in fact, if I move this, I'm going to move this a bit so that sensor 3 is no longer pointing at the camera. There we go. So now that is the entrance sensor, that is the middle sensor, and that is the exit sensor. And in fact, I'm going to switch to this view so that you can see what I'm doing. We're going to go entrance sensor, middle sensor, exit sensor. And now you can't see it, but that's what I was doing before when it was reporting on the console the distance to these time of flight sensors. So all three of the time of flight sensors are working. Hooray! We have PCB detection. So if I had a PCB and I slid it along there, I get the in, then I get the center, and then I get the exit coming up. So nice. All right. We might be closer than I thought to having this thing working. I need to connect the stepper motor driver to that. I need to connect the homing limit switch to that. In fact, what I could do, let's see if we can make this, oh no, it won't run the stepper because I haven't connected it. What I was thinking of doing was connecting the limit switch, and then we could make it do a homing routine, but we can't do anything. I could trigger it manually, but we're not actually going to see anything much happening because we don't have this connected. And that does not go directly into there. This goes into a little control board, the stepper motor driver board, which then connects into there. So I need to cable all of that up. And it is now 12:15, so it is time to stop. But I think, okay, let's regroup, people. Let's regroup. I think that, oh, hang on, there is interesting stuff in the chat. Let's bring this back. Let's bring this back. Crispian says, big things coming up for us. We're going to miss our Mount Lura hill climb next weekend because Emmy is going to hospital. No, the following weekend is drag racing at Ballarat Airfield on the 29th. But, sorry, are your priorities right? Because you went from saying Emmy is going to hospital to following weekend is drag racing at Ballarat. Okay. Don't be thinking about the drag racing right now. Be more concerned about Emmy going to hospital. I know. I'm sure you are. I'm sure you do actually have your priorities straight. I'm just giving you a hard time. Which one is the existential sensor? Yeah, existential questions. Let's not ask those right now, please. Don S says, use the middle one to trigger inspection cam. That is a really cool idea. What I could do is I could have a like a Raspberry Pi camera mounted over it and have it so that it brings the board to the middle, pauses it, takes a photo, and then moves it on. Yeah. Okay, so Austin said, the only potential issue, Alan, is that this is designed to talk to other machines and report to MQTT for possible errors or to stop so you can inspect before next PNP machine or event. Yep. Yes, so Alan Madsen says, so G0X100 to go to the middle, and then G0X100 to go to the oven. Imi says, come on, will TTS catch it? Is it? Is it? I don't know if TTS is actually going to catch this one. Imi was saying something. Yeah. Yeah, so Sion says, but the middle sensor will detect at the leading edge, not the PCB center for camera view. Yes, that's right. Yep. Now, there are a couple of things that can be done. All right, so in terms of design, the original design, my original goal for this, I flip-flopped. My original prototype used those little N20 DC gear motors to run the conveyor, and because they're cheap, they're simple, they're reliable, they run at a constant speed, etc. They're generally good. And then I decided what I was going to do was replace them with micro stepper motors, so that what I could do is detect the board coming onto the start of the conveyor, move, and then by doing step counting, know exactly how far along the board had moved. And then I could have software set trip points. So I could say, in software, detect a board and then move it to 227 millimeters along the conveyor, and it could all be tuned in software because you've got control with the stepper motor. But I ended up slightly redesigning it to go with steppers, and then I changed my mind and I thought I'd go back to N20 gear motors. So this current design is back on the N20 train, and I am doing it based on a known movement speed. So we can do it based on time, approximately. And it doesn't need to be super accurate because these conveyors are not being used to move a board to a known location so that you can then do pick and place on them or something like that. It's just you want to know approximately when it's entered the conveyor, you want to know when it's cleared the conveyor, and you want to be able to put it somewhere in the middle or at a certain distance along. And my feeling, not yet verified, is that I should be able to do that accurately enough by detecting the leading edge of the board, so I know when the board has entered the conveyor, and I know the speed of the conveyor in millimeters per minute, or whatever the calibration value is, typically millimeters per minute for conveyors. So if I know that it's moving at 900 millimeters per minute, and I want to move it a certain distance along the conveyor, then I just move it for the appropriate number of milliseconds. Blink, blink, blink. Okay. Yeah, Immy, it isn't saying it. I don't know why that isn't working, but there.
Imogen Ann said, blink 5 times if you're under duress. Blink, 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 lol.
That was my smoke signal going up. I am under duress. Duress and stress. Yeah, so I was actually even considering not putting the middle sensor on at all. I've got it on there kind of as an experiment, but I think that I can get away with just an entry sensor and an exit sensor. And I may not even need the middle sensor because I can configure how far I want to move things along the board by setting the time interval, like the run time, which can be calculated based on the speed. Because if we come back to here and look at config, no, not config, G-code, no, is it G-code? Process G-code messages, yes. So if we say run G-code move, no, spindle, M-code messages, here we go. So conveyor speed is in millimeters per second, and so we know what the requested speed is. So we can use that information to determine how long we need to run it to move it to a particular location. I wonder why CAN messages is disabled. I don't know. Alright. I think today has been enough of a reorientation that I can actually make some decent progress. Yesterday was assembling the hardware, putting the mechanicals together. We've just validated that the PCB sensors work. What I need to do is finish the mechanical assembly, put the linear rails on it, connect the stepper motor so that then I can get back to the firmware and we can make this do useful things. Get it homing again, getting it running at controllable speeds, etc. Oh yeah, and this is M10S position request status of a sensor. Oh, okay, interesting. So that's something I haven't implemented yet. Sets the direction as clockwise, sets the direction as counterclockwise, stops the conveyor. So I'm using M3, 4 and 5 as the run. G0Y distance, move to the size, do a homing. Yeah, so all of this is actually already implemented in the G-code parser and in the movement control. I don't have M10 position. At the moment, nothing is being done with the... Okay, so at the moment, this will run as a dumb conveyor where you tell it to move and it moves. But it's not going to do anything with the values coming back from the sensor because at the moment, all it's doing is... Oh, excuse me, debug sensor values. There is no, we're really just getting to the starting line here. We are validating that we can control the stepper, we can home it, we can set it to a correct width, and we can run, we can run at a speed and we can detect things. Next, we need the whole state machine that is going to run this based on requested actions and positions of boards. So we need to be able to do it, to tell it things like, send a command which is ingest a board, and then it'll check that it's clear and it'll run the conveyor, detect when the board comes on, move it to the stop location and stop, and then report that yes, I have ingested a board. And then we need to do the command for send a board, emit a board, which will have that whole, once again, that whole little mini state machine for the series of steps it needs to go through to complete that command. So there's going to be a fair bit of firmware work to do once the basic mechanicals, the sensors, the actuators are all up and running. Yeah. Alan says, with steppers you can do it on the length. When you know how far it is to the middle of the conveyor, also take the length of the PCB divided by 2 and subtract it from the length, and it always stops in the middle. Yes, that's right, but what I was saying earlier is I think I can do that exact same thing with the DC motors because we know how fast the motors are turning. So we've got motor control here, well there's the homing of the axis, there's set the conveyor speed here, we've got the PWM control of the DC motors so we can make them run at the correct speed, and where is it, in config we have somewhere in here, can I see ready and ready out, where is it, motors, PWM frequency, yeah, I need to do calibration, steps per millimeter, that's for the y-axis. I need to add the calibration based on the rotational speed of the motors and the diameter of the shaft, which is already done, like I've got all the calculations here, so that if you tell it to move at a certain, here are my calculations, here are somewhere prepared, what's the date? January 2024. Here are calculations I prepared a year ago. So if we tell it to move at a certain speed, we can do those same calculations and we can do it with DC motors. We don't need steppers. Nachos. Oh, I am so hungry. Yeah, Don S says, needs to ask downstream module for status first. Exactly, if you're going to. So we need, there's a ready in connection and a ready out connection, and those are the upstream and downstream connections to the machines adjacent to the conveyor. So that machines always need to be able to coordinate with the adjacent machine to move pass things along successfully between them, which can also be coordinated at the higher level because all of this is done through CAN bus, and we can send commands via CAN bus to the different devices and have them, like we can tell that machine and that machine to run and move a device between them. Oh, okay. I am so hungry, and I'm sitting here on a cold, rainy day when I should be snuggled up in bed. I really should be. But maybe I'll do some welding instead. I'm very tempted to do welding instead. Will I, won't I, or will I continue with this conveyor? I don't know. I don't know. Don said S88 automation standard. S88 automation? I don't think I've heard of that. This sounds like something I should know. S88 automation standard. Here. Provides a structured approach to batch process control, defining equipment, procedures and recipes to ensure consistent and reproducible batch production. What is this? 88 standard. Methodology, pharmaceuticals, chemicals, food, beverages, electronics. Okie dokie. Held, restarting, running. This look, paused, pausing, resume. So this is the state machine essentially for, yeah. Okay. Cool. Don S, thank you. This is exactly the sort of thing that I need to implement. So, to bear. Amanda said to Crispian, sorry, no, where is it? To bear. This is another one of those classic typos, I think. Amanda. I like this typo. So this is talking about pizza and beer, because it is, yeah, nachos and beer, Crispian said, and Amanda said, sorry, no beer, I am anaphylaxis to beer, so you don't drink. Yeah, beer will kill anyone. If you think that you can fight a bear and win, you are wrong. The bear will win every time. And yes, Amanda, I know you meant beer. Anaphylaxis to beer. I don't drink beer either. I don't like it. I'm not allergic to beer. I just don't really like the taste. But yeah, beer will definitely kill you. It'll kill you dead. Even a little bear. Okay, so I am going to take a note of this, and I am going to stick it in my, no, not there, not ASCII table, in here. PCB conveyor 2, I'm going to add it in to do. Read that. It is now in my notes, so I can steal other people's hard work and maybe implement the state machine based on that S88 standard. Alan said, if the gun is big enough, you win and not the bear. Oh, Jordan says, yeah, all depends on the equipment you have at your disposal. I'd happily take on a bear with an M1 Abrams. Yeah, that's true. You could just sit there in the M1 and eat your tacos and drink your beer while the bear is getting very angry outside. Yeah, that's true. I was thinking of my mortal flesh versus a bear. My mortal flesh would lose every time. Okay. I've lost the plot. My mind is gone. I want to go back to bed. Okay, thank you very much for coming along. I think next week we are going to make serious progress on the conveyor, and I'm going to make some progress in the meantime anyway. I will have the mechanical sorted so that next time it can be firmware. And then probably following after that, getting back to Testomatic, by which time the 80559-3R should be hopefully sorted and we can do cool things with Testomatic. So next week will be PCB Conveyor Part 2, and then week after that can be Testomatic. Thank you very much for coming along. Hang on, what was this? Don said, sorry for your lost wagon loads. What did I miss? What did I miss? Hang on, going back. Oh, yeah. Wagon Load says my mum died on the 14th. I missed that in the chat. I'm sorry, Wagon Loads. Yes. Yeah. Wagon Load says we need your prayers. Yeah. Okay. Wagon Loads, that's a rough thing to be going through. Yeah. If you need to chat, then get in touch through Discord or whatever. Yeah, as Jack Tech said, condolences. So Wagon Load says her name was Kathleen. I'm very sorry to hear that, and I hope that you do have friends and family around to support you and help you through that. There was yes, so Lucian from Opulo lost his mum only a few days ago as well. I think it was maybe early in the week, and so it's a rough thing to go through too. The message I sent in that situation as well was that losing a parent is like losing an anchor. I have not gone through it, but so both my mum and dad are still around. But losing a parent would be like losing an anchor in your life and starting to feel a bit adrift. So it's a tough transition to go through, going into a new phase of life, really. I've got no idea what the relationship was like between you and your mum, but regardless of it, of how good or bad the relationship was, it would still have to be something that would be, it would shift the foundations of your life. So I hope you get through that situation, and that you have good people around to support you. So, yeah, okay. Hang in there, wagon loads. And I will see you all next week with progress on the PCB conveyor. So, thanks for coming, and I will talk to you all soon. Okay, bye.